Well, welcome everybody to our workshop today, Understanding Water Quality for Food Safety on Produce Farms. My name is Fern and I will be your host, and Rafi is my co-host. I'm glad you're all here, and we're going to be getting things started in a minute with Lisa McKeag. And Lisa is an educator with the UMass Extension VegetableProgram. She works with commercial vegetable growers throughout Massachusetts on topics such as integrated pest management and produce safety, including understanding and meeting the requirements of the Food Safety Modernization Act. Before we jump in, I have a few details to review with you. We are using our land acknowledgement. Rafi, can you pop that one in? This map can be found, and we'll show you the link in the chat. We're presenting, attending, and hosting this workshop from land that was managed and inhabited before European colonization. Take a few moments to find your location on this map and honor those whose land you now occupy. We make every effort to get to questions that you have asked during this workshop. We will be asking questions as they come up. Please add any questions right directly into the chat so we know, or you can raise your hand. Please feel free to use the chat feature and ask any comments. And like I said, we'll get to you as soon as we can. Let's see. To speak, simply click the microphone icon at the bottom of your screen, and please mute yourself throughout the entire thing unless you have something to ask. You can save the chat. You can go to the bottom of the chat at the end of this workshop, and you'll see 3 little dots, and those 3 dots will say Save Chat, and it will download to your computer. And we have some wonderful sponsors that keep NOFA going for these conferences and year round. We want to make this conference accessible to everybody as much as we can, and we encourage you to purchase from them. And when you do, let them know how much you appreciate their support from NOFA Mass. Take a moment to explore the virtual vendor marketplace, where there is a lot of great information and some generous discounts for conference attendees. And most importantly, we want to thank you. Thank you for spending the weekend with us, and especially for our NOFA members who make our education advocacy work possible. So at this point, I would love to pass it over to Lisa. Welcome, Lisa.
Thank you so much. I'll go ahead and start my thingy here. Okay, that look good? Okay, so hi everyone. Thanks so much for joining, and thank you, Fern, for the introduction. As Fern said, we're here to talk about water with respect to food safety. So I had a plan when I originally submitted my proposal for this talk. I had a plan to talk about water testing largely, but I had a plan that got a little bit upended by the release of the FDA's new proposed rule for the water provisions under the FSMA produce safety rule. I don't know if anyone is aware of that, but you will be in a few minutes if you're not. The release of this rule was kind of big news in the produce safety world. We've had to kind of reconsider, or I've had to kind of reconsider what I wanted to present for this session. But so this is where I landed, this outline that you're looking at here. We'll do hopefully some introductions if you're willing. I'd love to hear from you a little bit about why you're here. And then we'll talk about the regulations, because that really is kind of what drives a lot of this conversation. Cover pretty briefly just some fundamentals of food safety to get into then finally the conversation about mostly pre-harvest water management. And then I'll tell you about a project that I have going with the Department of Ag to do with water testing, and I'll share a few resources with you. So that's the outline for this session. So I am curious if people are willing. Oops, I think I just moved my thing here. If people are willing to share either in the chat, or you can unmute yourself just brought you to a session on food safety, because I know that there are, and particularly water, because I know that there are a lot of other great topics at the conference. I'm just curious why you're here. And I'm putting up on the screen here some kind of guiding questions. If anyone's willing to unmute themselves and chime in, I'd love to hear it.
Morning.
Morning.
I've just taken on a role with NOFA, New Jersey, excuse me, and I'm interested in FSMA, I'm interested in water quality, and really, I'm sorry, any more in-depth technical kind of practices and information that we can get our hands on, because a lot of our farmers are spread so thin that they don't have time to dive deep into every different topic. And some farmers specialize in taxes. I was just talking to one that got deep into how best to prepare their taxes, but I'd like to increase our programming of technical support and knowledge on these issues and bring them to our farmers. So that's what I'm here for.
Great. Thanks. Nice to meet you, Devin. Anyone else want to share what they're interested in about water and food safety?
Hello, I am Luis. I will be joining a team for social equity cannabis indoor growing in Malden, Massachusetts. And I'm coming from Vermont. We do have a good program for water quality and farms over there, but I'm open to learn on any technicalities on water in Massachusetts.
Great. Anyone else have anything they want to chime in about their concerns about water, or just sort of interest in this topic? I'll go ahead and move on. Thank you so much, Devin and Luis, for sharing that. That's helpful to guide where I go from here. Okay, so Devin, you mentioned FSMA, and that is probably the biggest reason that I think farmers care about food safety to the degree that they do right now. But there are certainly other factors. I think a lot of the big notable cases in the news are really drawing people's attention to this, this concept of just caring about food safety and thinking about making sure that their produce is safe from contamination. There's a big outbreak of E. coli 0157H7 that was in spinach way back in 2006 that really helped to move this legislation to where it is now. And given all this attention, and there's been actually more recent outbreaks, romaine lettuce, there's like almost annual E. coli outbreaks in romaine, it seems like, over the last few years. And even though a lot of these incidents have been tied to more West Coast farms, California and Arizona are the big growing areas, particularly for leafy greens. But given all this attention, even though none of these incidents have been tied to farms in Massachusetts, that we know of, growers they're really paying attention. And I do hear it a lot from growers that they want to do the right thing and to protect their customers, particularly farms that have, more vulnerable customers. They might be selling into CSAs that serve markets that have a lot of young kids who might be more susceptible to the really bad effects of having a foodborne illness, or part of farm to school or farm to institution programs, things like that. So people want to protect their customers. They also want to avoid liability. That's definitely a big one. There are definitely some notable lawsuits related to the bigger cases of foodborne illness outbreaks. Protecting the ag economy is also a big consideration. We had those romaine recalls after the outbreaks, again, related to kind of California and Arizona growing areas, but those affected East Coast farms too, because all romaine was recalled at that point, and nobody wanted to eat a Caesar salad for a little while after that. So it really affected just how the public perceived the safety of produce or fresh produce. But so another topic, another sort of reason why people are caring might also be efficiencies. There are, when you start to pay more attention to your systems and thinking about food safety, that often just leads to sort of better organization overall and better training of your employees. You might have some of your protocols written down in a more kind of concerted way. So food safety ends up being just kind of a byproduct of like a better overall organizational system sometimes for your farm. And finally, some growers need certification if they're selling into, say, like a grocery chain, Stop and Shop or something like that, will ask for a certification. And so there have been audit programs for a while, but FSMA is really moving this along where buyers and even customers are asking the people that they're buying their produce from whether or not they have, you know, food safety certifications to demonstrate that they're using, excuse me, some of these safe practices. But still, I'd say that the biggest driver is the FSMA, the Food Safety Modernization Act regulation. So that's where I'm going to start, is with the regulations. So these next few slides are a little bit dense, and but this is the legal aspects of some of this stuff. So I think that this is really important to at least have some of this language down and an understanding of what these rules say. Okay, so FSMA, the Food Safety Modernization Act, is the sort of big rule that it was passed actually way back in 2011, law. And it was the law tasked the FDA with coming up with these rules to focus on prevention of food safety or foodborne illness outbreaks, rather. The FSMA produce safety rule is just one of 7 major rules that are part of the whole FSMA. That is really where the kind of modern Food, Drug, and Cosmetic Act started. So the food chain has been regulated for a long time, but this produce safety portion of it is kind of what's one of the really big things that's new about it. But another thing that's new, and why the whole FSMA covers the entire food chain, is there really is this focus on prevention. FDA historically has been kind of a responsive agency. They would respond to, you know, adulteration in the food chain or mislabeling on products in the food chain. And the whole idea with FSMA is to really work on implementing practices and overseeing that farmers and food manufacturers and everybody sort of in the food chain are following preventive sort of best management, risk management practices. So then, particularly for produce safety, which I've said is, you know, that one sort of slice of the pie that wasn't regulated previous to the FSMA produce safety rule, that's pretty new. And so it is a kind of new experience for farmers to be regulated to this extent by the FDA. And what the rule does, the produce safety rule, it just sort of sets minimum standards for good agricultural practices, sanitation practices and stuff that will hopefully help to prevent foodborne illness and pathogen contamination of particularly raw agricultural commodities. We're talking about fresh fruits and vegetables. Those are the commodities that are covered in the produce safety rule. And that rule, the law was passed in 2011, and that produce safety rule was published in 2015. So it took them a while to come up with, took FDA a while to come up with what the rule actually said. It was open for, you know, comment period for quite a while, but the final rule was published in 2015. And in under that is the bullet here about where you can find that in the Federal Code of Regulations. So it's this section in the Federal Code, and it's subparts A through R, which I note because what we're talking about is subpart E, agricultural water. So everything for the most part related to agricultural water is under this subpart E. So if you're paying attention to the news or you hear this sort of in your work, that subpart E was released. That's the rule that I was talking about that kind of made me rethink how to present this program. So that's everything related to agricultural water. And in this box here, you'll see that what the rule primarily says about that, this is the big, that's why I've got it kind of highlighted here, is what your requirements are with respect to water, is that all agricultural water has to be safe and of adequate sanitary quality for its intended use. So that's your kind of guiding principle as you think about water on the farm. And these are highlighted because each of these terms, agricultural water, safe, and adequate, are all defined, regulated terms, either within the Food, Drug, and Cosmetic Act as a whole, or specifically within FSMA. And this adequate term, you know, it's a little squishy. It's a kind of a squishy term. It's that which is needed to accomplish the intended purpose in keeping with good public health practice. And so all of your sanitation practices and making sure that your water is of high quality or adequate quality. That's what you're shooting for. And so it becomes kind of, the onus becomes sort of on you and with educators and the regulators that you might interact with to determine what adequate means in order to protect public health. Okay, so right now what FSMA says, what the produce safety rule says, is that is this stuff. So these are all the kind of, we're not going to get super into the nitty gritty of all of what these details say. Oh, and I meant to say early back on, I'm going to scroll back for a second here, that if people do have questions about whether you yourself or the farmers that you work with do have to comply with the FSMA produce safety rules, I put a picture of this tool here that we have on the UMass website. And I know that other state extensions have some similar tools, but this is just a picture of our website. And there's a link here, which we can share in the chat, or I'll share later, where you can just walk yourself, or a farmer can walk themselves through this interactive question and answer to say, like, am I covered and to what extent, and some of the details of that. So if the growers that you work with do have questions about that, there are easy ways to figure out if you do have to pay close attention to what the rule says, or if you're really focused on just sort of the general principles that we're going to cover. But I do think it's important, again, to kind of cover the details of the rule. So the rule as it's written, the agricultural water parts are these things that it applies to covered activities, covered produce, and again, that covered produce is generally produce that is generally eaten, generally consumed raw, not generally, but likely to be consumed raw. And that is a defined term. And again, we're not going to get into, again, all the specifics of the coverage or non-coverage, but just keep in mind, we're talking about, fresh fruits and vegetables for the most part. And the agricultural water is that which is sort of intended to or likely to contact covered produce. So the things that you're using in your irrigation and produce washing, that kind of thing. So you also have to inspect your water systems. You have to stop using that water that you're using if it's not adequate, and use corrective measures before you resume the use of the water. And then you have to, the rule is written, this is that all of these other points are important to note, even if we won't get into, again, all these nitty-gritty details of all the numbers, but you have to establish this water quality profile, which consists of the results of a number of different water tests, depending on what the water source is that we're talking about. And then you take all those water tests and you determine other numbers. The tests are for generic E. coli, and you're looking for pre-harvest water, anything that you're using while the crop is still in the ground. You want to determine the geometric mean and the statistical threshold value, and they have to be these, the water has to be of a certain quality according to these metrics. So the most important, why I'm showing you this, is just to demonstrate that this is a pretty prescriptive part of the rule. It's really the most prescriptive part of it. A lot of other parts of the rule really lean more towards that sort of, is this adequate? And you kind of have to determine that based on all kinds of things. But there aren't a lot of metrics in the rule, but this water rule as it's currently written does include a lot of specific metrics. There's specific methodologies that you have to use for testing generic E. coli. And the point I'm trying to say about all of this is that this rule, as it was written, as it's currently written, has gotten a lot of feedback from the public, from growers, from regulators, even from educators, about how kind of complicated, expensive this might be to implement. You'll see that there's 20 water tests that you have to start with to get this MWQP for surface waters, and then you have to take 5 more tests annually. And that, some growers have many surface water sources, and this was going to get very expensive. So there's a lot of feedback from the public about this, particularly the water rule. So in 2019, a few years after the rule was finally published, 2019 FDA decided to revisit it. And so they extended the compliance dates. The original FSMA compliance dates have already all passed. So even the smallest growers that are covered by the rule are required to comply with most of the components of FSMA at this point. But for the water rule, they extended those years out by quite a few. And you can see, for very small businesses, the compliance date's still in the future for anything related to water. So even big businesses still had 6 years from the final passage of the rule to comply with anything water related. And this is the FDA's language about what they were trying to do. They wanted to revisit this rule to make sure that it could be implemented and that it was not overly burdensome on growers, that it had some flexibility in it, depending on, the scale of the farm. For small growers, they're going to have maybe different risks and different budgets for things like testing than the big growers. I have highlighted in red here that January 26th is the first compliance date for all these water related things. And you'll note that that is this month. And so also wanted to point out this last bullet, the FDA does intend, they said, to exercise enforcement discretion for all of these agricultural water requirements as they're currently written while they revisit that rule. And so what that means is that they're not going to regulate on this. They're not going to regulate farms. They're not going to expect farms to have complied with this rule as of yet, unless there's some like really egregious condition. They're not going to be looking for people to be in compliance with the rule as it's written, because they also, and this is the rule I mentioned at the very top of this session, FDA released a new proposed subpart E back in December 6th. They released this rule, and these are the details as they currently exist. And the proposed rule does still apply to water that's used in covered activities likely to contact produce. You do still have to do an annual water inspection to make sure that you're identifying your hazards. You do still have to discontinue use of the water if it's not adequate in your assessment. But all this other stuff goes away, at least for pre-harvest water. So this proposed rule proposes all of those things that I just mentioned that it had in common with the original rule. But then instead of the water testing and all of that really prescriptive stuff about, how many water tests you have to take and this threshold that you're trying to stay under in terms of your generic E. coli, what it proposes is a written agricultural water assessment. And you would do that at least once annually. And in part of that assessment, you're being asked, at least as it's proposed, for all of your pre-harvest water, that you identify what the source is, the source of your irrigation and other water that you might use for crop sprays and that kind of thing. You need to identify, is this a ground source, like a well, or a surface source, like a pond? Is the water distribution system closed or open? Is it all underground? Is it all in pipes? Or do you have, open holding tanks, things like that? What are the crop characteristics that you're using the water on? So you have to consider the particular risk of the crop that you're, leafy greens are going to be more risky than some other crops potentially based on just the leaves themselves and their susceptibility to contamination. You have to think about environmental conditions, like did it rain, were the leaves damaged, and then other relevant factors, and that would include the results of any test that you're taking. And then the rule also expects you to, or this again, as proposed, consider adjacent land use activities. So whether or not there's animal activity, things that might affect the quality of that water. So I'm not going to get too much into the rest of the session isn't going to be tailored necessarily to specifically this proposed rule. I think there will be a lot of comments to FDA about this, and it is open for public comment right now, which I'll talk about in a second. It may change in its final form, so we're not going to, specifically speak to the rule as it's written, but keep in mind that what they're looking for really, and where the FDA is sort of heading with their considerations about how to regulate agricultural water and how to work with growers to prevent contamination of agricultural water is through this sort of broader risk assessment. So a risk-based approach to thinking about your agricultural water rather than these specific metrics that you're trying to target. Yeah, so again, I just want to note that for post-harvest water, that's anything once you've cut the plant or harvested it, taken out of the ground. There are different requirements. They're stricter requirements. So there are still testing requirements for post-harvest water. Anything that you're, washing your vegetables in, washing your hands with, there are still testing requirements for those. Those don't get taken out for this proposed rule, and also for sprouts. So sprouts are definitely a more high risk crop, and water plays a bigger role. And folks who grow sprouts, which isn't a ton of people in Massachusetts, have already had to comply with certain water requirements for sprouts. So there's no change there for those post-harvest components. Okay, so here's a picture. This is where you can see the rule on the Federal Register. You can read through it yourself if you would like. And there's actually a lot of, if you are interested in this topic, there's a long preamble to some of the details of the rule that kind of tells you a bit more about FDA's thinking and how they decided to sort of change what they had originally finalized and now what they're proposing. So you can read the rule, you can access it at this link, which I can share with you at some point at the in the chat or in a resource list that I'll give you. But I do want to note that there are a couple of different ways to comment. You can comment directly in the docket. I think either of these links actually will take you to this page, and this green button here is where you can submit a formal comment if you want. And then there are a couple of public meetings that you can attend next month where you can interact directly with a representative of FDA. You can ask questions, and you can make your comment known there. And I do want to note it for this and for any other time that you might be commenting on a regulation, a proposed regulation, note that it isn't just a matter of just putting in like, I hate this, go away, I'm not going to do it, leave me alone, FDA. That really comments that are thoughtful and substantive and talk about your own work and your own experiences, and alternatives or solutions that would work for you. That if you submit those in a comment, the FDA is much more likely to consider them and to really use that to affect the rule. And there was already a big public comment period before the final rule was proposed, and even after the final rule, so much public comment led FDA to revisit it and really change it significantly. So know that that public comment really does have an impact on how some of these regulations get written. So consider that when applying or replying to either this or other rules, and note that the comment period ends on April 5th of this year. So that's the rule as it stands and as it's proposed. And I'm just going to say a little bit more about regulations before we move on to the next section. I'll say that in Massachusetts, as in most states, the FDA doesn't enforce the rule directly. So you're not generally going to have an FDA person come to your farm. In Massachusetts, again, as in I think most of the states, there's a state agency, and it's usually the Agency of Agriculture. So in Massachusetts, that's the Massachusetts Department of Ag Resources. That is the enforcement agency for the rule. So there is farms that are covered under the rule. You will at some point get either an inspection or at least a visit or a communication from MDAR. Even if you're not, you'll get if you're a commercial farm, you're likely to get some sort of communication from MDAR to determine whether or not you are covered under the rule. And then if you are covered, they'll be the ones conducting the inspection. Some states do have their own regulations. So there's the federal regulations under the FSMA ProduceSafety rule, and then there's often state regulations. Massachusetts did just promulgate their own regulations related to ProduceSafety. And those you can find here at I don't have the link up, but you can Google 330 CMR 34. That's where it exists in the Massachusetts Code of Regulations, ProduceSafety and Market Access rules. And they are aligned with the FSMA rules, although their state rules can't be less strict than the federal rules, but they can certainly be more strict or include additional elements. I don't think much deviation between the state and federal rules at this point, but just note that they can add things like a written farm food safety plan, could be added in. I don't think that's specifically in there at the moment. I will note that the state regulations do have, as they're promulgated, do have all of that water testing and all of that, microbial water quality profile stuff in the regulations. But and so that is current in the Massachusetts regulations, but if the federal regulations were to change, MDR intends to update the state regs to agree with the subpart E as it is finalized eventually. Okay. One last thing about all this kind of regulatory stuff is that there's also audit programs which are voluntary. So anyone who's, any commercial producers can opt into having their farm. You can actually opt into having your farm inspected if you would like to. And then you can also opt into having your farm audited. So you would get with an inspection, an inspector will come, but they're not going to give you a certificate that says like, yes, you're doing all these practices. They're just not going to like, you don't get a certificate every time you drive your car and you have your license and you don't, have any infractions. You're just following the law. But for particularly for buyers and people looking for some certification that you're demonstrating that you're following some of these good agricultural practices, buyers want to see some sort of certificate. And so that's what an audit is for, where it's, usually a checklist based process. And an auditor will come to your farm and sort of, verify that you're following some of these practices. And so that's the same, it's MDR, it's the same team that does the inspections as does the audits. And so we have a thing, it's a marketing tool in Massachusetts called Commonwealth Quality. And a Commonwealth Quality audit that someone might opt into, is successful completion of that audit is kind of de facto compliance with all of the regulations, federal and state regulations. So and then along with the audit process, so you would reach out to MDR and say, I'm interested in having someone from MDR come and walk through my farm with me, and they'll do technical assistance and all kinds of educational outreach to make sure that you understand both the rule and the audit program, and help get you this certificate. And I think you get with like an annual recertification of the certificate. So, and I just want to point out that the Commonwealth Quality Program does currently have testing requirements in it. So I think 2 to 3 tests annually, depending on the source, if it's a groundwater source or surface water, and those will be retained, even if the testing requirements, I think, are removed from the FSMA produce safety rule. So that's all the stuff that I wanted to say about the regulations and the proposed rule. Does anyone have any questions at this point? Okay, hearing none. Move on to just some basic fundamentals of food safety. So in all of these rules and certificate programs, what are they looking for? What are we talking about when we're talking about food safety? What do you need to be able to demonstrate? I keep saying good agricultural practices, and really, what does that mean? And we'll talk generally about what I mean by that. And Vern, I just want to check in again. There were no questions about the first. Okay, so we know that foodborne illness affects human health, affects the economy. Major outbreaks have really been tied to the big production areas, like I said earlier, the big packing facilities that maybe commingle products from different farms, and California and Arizona, particularly. I keep mentioning those places because they've been in the news in recent years, where those are the big lettuce growing areas in the country, and there have been some issues related to produce coming out of those areas. And to what extent this is an issue here in the Northeast, to be honest, we don't really know. And partly that's because illnesses likely go underreported. I will say that according to the CDC, produce has been implicated in almost half of foodborne illness outbreaks in recent years. So we know that there's a connection between the potential for produce to harbor pathogens and we don't totally know to what extent that really is affecting people, particularly with kind of a shorter supply or a shorter, chain between the producer and the consumer. And I have this box over here on the right that just sort of highlights why that might be true. It's just sort of a little thought exercise to think like, okay, there are estimated almost 50 million cases of foodborne illness every year based on reported cases and some other evidence. And but if you kind of think about your own experiences and those of the people so of all of those potential cases, there aren't that many people relatively who, might go to a doctor for food poisoning unless it's, really severe. And then if you do go to a doctor, physicians aren't necessarily going to take a stool sample. They're not necessarily going to send it to a state lab. And if they do, that state lab doesn't always report it to the CDC. So you kind of think about it this way, where there might be a number of cases, and then fewer and fewer people to be able to sort of say, this particular illness is related to this particular illness, and they're all tied back to a single source. And then that trace back, even if you understand that the illness has occurred, can be really challenging, and figuring out why the contamination happened in the first place can be really challenging, which is why this whole FSMA thing really focuses on prevention, because like figuring this stuff out after the fact is really challenging. And so it's really this emphasis on like, well, let's think about the practices that we understand are likely to make food generally safer, and focus on those things. With produce in particular, there's no kill step a lot of the time. So if you're eating raw produce in a salad or otherwise, or not cooking it all the way to the point where pathogens might be killed, that allows the contamination to persist throughout your, up until when you eat it. And contamination can be sporadic. We'll talk about this in the next section, but there are different ways that these microorganisms can get onto produce. And once they're on there, once you have a, E. coli cell or E. coli on a, lettuce leaf or something, it's hard to get off of there once it's on there. And so really, again, focusing on prevention through these risk reducing practices is what we're trying to focus on. And this is just to remind you what we're talking about when we say contamination: fecal pathogens. So animal feces can contain pathogens that make us sick. That's, human animals, other animals in their feces can be pathogens that make us sick. There's all kinds of microorganisms in feces, and some of them are pathogenic. And so the best shorthand I've ever heard for this is keep the poop off the food, which is kind of just the general shorthand that you're looking for. You want to keep the poop off the food, which is really just all about managing your risks, and keeping poop off of food really seems maybe easy enough, but again, we're talking about microorganisms, and these are they're really small. You can't see them, and there are a lot of different ways that they can get onto food and into water and survive in water, or replicate in water in the case of bacteria. So you have bacteria, parasites, viruses. These are the microorganisms that we're talking about. Bacteria being, pathogenic E. coli. There's lots and lots of E. coli, and very few of them are pathogenic to humans, but there are some strains. E. coli 0157H7 is the one that maybe people have heard and read about, because that has been involved in recent outbreaks, but also salmonella. There was a salmonella outbreak in onions that was going on for most of last year. Then also parasites. Think of things like Giardia or toxoplasmosis is a disease that's caused by a parasite that can exist in cat feces. And then also viruses like noroviruses. So these are all things that can, in the case of bacteria, survive and grow in water. And then parasites and viruses can also be moved around in water. And just think about the way that water kind of moves around your farm. And that's why it tends to be one of the big categories that we think about when we talk about food safety. So speaking of categories, these are kind of your major risk areas. These are the big categories of ways that poop, or the pathogens that are found in poop, can get onto food. So if you take a Produce Safety Alliance grower training, which maybe some of you have heard of or have taken, you would go through a whole day talking about each of these topics, and water is a really big one. It gets 2 modules in that training, and I have borrowed parts of that training in you'll see later in the presentation. There are a few slides that I take directly from that training, and you just want to learn to identify where the risks are and take steps to prevent them, and look at kind of all of your practices with this eye on food safety. So you have your this picture I've had in my files for a long time. We used to use this in our GAP trainings, which is an audit program that predates FSMA. These cows are standing in an irrigation pond. This is one thing you really want to avoid, is having animals immediately in your irrigation pond. But so these other risk areas also include this post-harvest water. So that'd be, again, your water that you're using for washing, all of your worker health, hygiene and training is another topic area, and represented by kind of these porta potties. You want to make sure that people are following sort of basic good hygiene practices, washing their hands, going to the bathroom in the right facilities, and that they're trained really well to understand practices and sort of who to report things to and that kind of thing. And then all of your post-harvest handling and sanitation, this picture has all of these, harvest bins and packing boxes and sorting tables and all that stuff. So you're thinking about all of those areas where that might get contaminated through the chain of events with pathogens. And then soil amendments is the next picture here. That's a pile of manure right next to a leafy greens field. That's probably something you want to avoid. And then of course, all the animals, so wildlife and also your domesticated animals. So thinking about kind of how your dogs and cats and other animals are potentially contributing to your food safety risks. And here's my goofy picture of your food safety glasses that you just kind of want to, through all of your processes, just to have this other perspective of like, how are my processes either helping to prevent or not prevent this potential flow of contamination. And I wanted to throw in this slide about risk-based thinking, just to temper that a little bit, because I talked about all those topic areas and noted that there are all of these different ways that your food can become contaminated. I just want to make sure that we understand the distinction between a hazard and a risk, where, in each of those areas, all of your, pathogens are the hazard. They're the agent that has the potential to cause harm. But how much of a risk they pose to you or to your produce is going to depend on your farm and your practices. It's the likelihood of the harm happening from that hazard. And so, I have this picture here of a shark is a hazard. A shark is something that can potentially cause harm, but the risk of a shark causing you harm only exists if you're anywhere near the shark. So the exposure is the key element that creates a risk out of a hazard. So you could go crazy if you consider every hazard a risk. You'll lose your mind. And so I just wanted to put this in here to kind of help remind us that we're not necessarily trying to consider every contingency and create a sterile environment on your farm or anything like that. You'll lose your mind. But really emphasize that risk-based thinking is more useful than this broad hazard-based thinking, that you really want to focus on your priorities in the places where there really is a high probability of risk and a high severity from that risk happening. So you don't have to worry about sharks if you never go in the water, and you don't have to worry about when it's safe to apply manure if you don't spread manure on your farm. So just sort of trying to focus in on the things that really are impactful on your own farm. And, water itself is not a hazard, but there is like we said, the risk for water to become contaminated with pathogens, and then the risk for your produce increases because water moves around your farm and everything that it touches could potentially be contaminated, and it can contribute to the degree of risk that's presented by pathogens. So it's a priority area to focus on because it has been a factor in foodborne illness outbreaks in the past and in recent years. So the romaine outbreaks that I mentioned, the pathogen strain that was identified in some of the illnesses was found in adjacent irrigation canals. And, in one investigation report, there was a tanker truck of water that was used for irrigation that was improperly sanitized. And so that water was found to have pathogens in it potentially. And so just included these pictures on the slide to remind you of all the different ways that water gets used or otherwise moves around your farms. And I have them broken out into these two categories because agricultural water does have a specific definition. It's a regulated term that, again, I think I mentioned at the beginning, where it's agricultural waters, it's water that's used in covered activities and it's likely to contact your produce. So this is, your irrigation water. And again, here's your irrigation pond and things that you're using for washing produce. And things that your water that you're using in your pesticide applications or other crop sprays. And then I do think it's important to remember all the other water that I'm calling other water. And here's some pictures of just, pooling outside of a wash area. And we've had this is a photo of my colleague from this past summer where it just rained for 6 weeks in Massachusetts, and things were just real wet. And so, and this, picture under that is a picture, this is from our research farm in Deerfield, where we have a, manure or compost making area that includes manure, and, it gets wet and it puddles and this water can move. And so, just want to keep in mind all that, how water flows around a farm and why it really is a primary risk area. So, okay, any questions coming in, Fern, or keep going? Okay. Okay, so now I'm finally going to talk specifically about water management. And I should clarify that I'm going to talk specifically, and I've said it a couple times, about pre-harvest water management, which is, all of these uses, irrigation, fertigation, if people do that, all of your pesticide sprays, other crop sprays, cooling. You might, be irrigating or, using water for strawberries in the spring, when it's still dipping into you might get a freeze or something like that. So any water that you're using before the crop is harvested. And then your post-harvest water is all these other uses, all of your post-harvest uses. The same principles are going to apply to post-harvest water as to pre-harvest water in terms of, managing risk and trying to prevent contamination from happening. Although the requirements for how you have to think about that are going to be a little bit different. So I'm really just going to focus on pre-harvest water in this talk, because post-harvest water, that conversation often gets into sanitation. And like I said, there are still testing requirements around that. And sanitizer use, and there's all kinds of conversations around that save for another talk. So here's a slide that's right out of the ProduceSafety grower training that I mentioned, which is a training that folks who are covered by the rule are required to take, at least have one person from their farm at least take that that training, which we do offer. And I'll mention that a little bit more at the end. But here's a slide from their presentation that is kind of just covers the ways that surface water in particular can become contaminated, although there are ways on here that groundwater also can become contaminated. Just a lot of ways that water can become contaminated, whether it's runoff or from manure applications, or animals either being in or near the water. You might have a septic tank malfunction, or even functioning properly when there's a lot of water, they can still leach pathogens and fecal contaminants into the soil and into the groundwater. This last part of it here, the things we never thought of is I think anxiety producing also, in that way that you can't consider all the hazards, but also important to keep in mind that you just have to think about your own systems and how your water may or may not become contaminated with pathogens. And I also want to note that the reason that, again, that I think water is an important thing to focus on is I think all of these issues are potentially going to get a little more critical with climate change, because we can expect, at least in the Northeast, heavier precipitation events, warmer temperatures, which means your plants may, be transpiring more, and so they may need irrigation more frequently. We also might have longer periods of drought, which could mean that your water sources could become of lower quality. So, if you have a irrigation pond where the water is quite low and you're still trying to irrigate out of it and you're stirring up sediments from the bottom, that could cause the water that you're using to be of lower quality. So I think climate change is another thing to keep in mind, as I think all of the things that we're talking about just may become bigger issues as water related issues in the Northeast become kind of more critical, again, as we're talking about more rain and potentially more ponding, more flooding on your farm. Okay, so how do you determine the quality of your water? How likely is it to get contaminated? The likelihood of it getting contaminated to the point that it may pose a food safety risk to crops depends on a lot of things. One big factor is the exposure of the source. So different water sources can inherently carry different levels of risk. So if the water is protected, if it's treated as with a public water supply, it's going to pose less risk. A treated public water supply, relatively low risk. However, many farms don't use municipal water for irrigating or for their crop sprays. A lot of farms use well water, groundwater, which is more protected under the ground, not usually treated. So it's more risk than like city water, less risk than, fully exposed surface water, river or pond or something. Groundwater can be affected by groundwater contamination, again, leaking septic systems, bad wellheads. So it poses some risk, but lower than surface water. And then surface water, it's open to the environment. It's dynamic. Animals can get in there, field runoff. That's where you want to focus, I think, your priority attention. So my recommendation is to start with just a general understanding of all of your water sources. And if you get a Commonwealth Quality Program audit, they'll ask you for a map of your distribution system. The current and proposed FSMA rules both require annual water system inspections, which might not require, a specific diagram, explicitly as part of your requirements for that, but it's really a good way to help you with a system inspection and help identify all of the sources of your water and then all the components within the system. So these are just some examples of ways that you can create a water system map, which again is like just a really helpful way to sort of picture what your water system is and all of the kind of adjacent things that might impact it. And I think that the Google Map tool is a really helpful one because you can kind of zoom out and say like, oh yeah, this forested area here, there's a lot of deer in there. They could potentially, like, how do I think about my specific risks all kind of pictured in front of me? And I think that's a really helpful way to think about your whole water system. You want to just ensure that the system is protected and that, identify the places where water can be contaminated. And, each of these pictures demonstrates that it doesn't necessarily need to be complicated. You just need to be able to sort of see it all together. I'm going to show you a video. Hopefully this works for all of you. It's short, it's like 5 minutes. So bear with that.
Hi, Lisa, before you do that,
Yeah,
we have a question from Dan.
great.
Wanting to know, he said he purchased a farm with interior hydroponic growing systems and outdoor field growing with on-site irrigation. Are you going to be talking about the testing process?
I will. Yep.
Okay.
Yep. Not specifically necessarily for hydroponic, but yes, I will definitely talk about
Just general.
Yeah, for sure. And I'll tell you where you can get your water tested and stuff.
Thank you.
Yep. Cool. Okay, so I'm going to play this little video. It's from Michigan State University, and they're another extension. They do a lot of work on. They're great. My colleagues there's a guy named Phil Toko who is at Michigan State, who is a really great food safety educator. Really funny also, which helps. But they put together this video on water system inspections that I just thought wrapped it up so well that I didn't want to summarize it. I thought I would just show it directly because it really does cover a lot of points of sort of just thinking about a water system inspection as a whole. So I'm going to go ahead and play this video.
Inspecting irrigation water systems is something that growers often do naturally without much thought to record keeping. Irrigation systems need to be constantly inspected and fixed to be kept in working order. From a food safety perspective, a number of key factors need to be considered. When evaluating the system, it's important to remember that a water system begins with a
Whoops. I screwed it up by touching something. Sorry about that.
inspecting irrigation water need to be considered.
There we go.
When evaluating the system, It's important to remember that a water system begins with the water source and extends all the way to the last emitter. Many gap audits require the grower to keep a map of the water system. Though not required by the FoodSafety Modernization Act ProduceSafety rule, it can be very helpful in an inspection. On a water system map, key components to be labeled might include water sources, including wells, ponds, and streams, potential sources of contamination, like mixing or loading pads or fuel storage, pressure sensors, and locations where hydrants connect to and terminate on the distribution system. Annual water system inspections should assess a number of key components. First, any inspection should guarantee the integrity of the delivery system. These are usually obvious from pressure sensor monitoring. If pressure sensors show an unexpected pressure drop in the system, a grower's natural response is to go looking for the leak. Regular checks to ensure the function of the pressure sensors may help avoid going on wild goose chases looking for leaks that don't exist. Apart from checking if pressure sensors are in working order, it is important to ensure check valves are functioning properly. This is only possible in those instances where a check valve is accessible. If the system a grower uses does not have an accessible check valve, one should be installed when making equipment upgrades. Another area of concern is the water intake area for surface water. In general, it must be kept free of debris, trash, domesticated animals, and other possible sources of contamination of covered produce to the extent practicable and appropriate under the circumstances. Checking for trash around the intake or anything the intake may have sucked to itself is essential to both meeting gap requirements and the FSMA ProduceSafety rule. If one of the sources of water is a well, it should be inspected as part of this annual inspection as well. Look to ensure the wellhead is locked and the conduit pipe for the electrical is present and secure enough to prevent access of insects and other animals to the well. The same goes for the vent hole. It should be screened to prevent access. If a concrete pad exists, ensure that it isn't cracked, as this may be a sign that liquid is infiltrating the bentonite seal below it and swelling, placing pressure on the concrete. Though not as in-depth as inspecting to ensure GAP's compliance, a FSMA ProduceSafety rule inspection requires several key components as outlined in 112.42a. At the beginning of a growing season, as appropriate, but at least once annually, you must inspect all of your agricultural water systems to the extent they are under your control, including water sources, water distribution systems, facilities, and equipment, to identify conditions that are reasonably likely to introduce known or reasonably foreseeable hazards into or onto covered produce or food contact surfaces in light of your covered produce practices and conditions, including consideration of the following: the nature of each agricultural water source, for example, groundwater or surface water, the extent of your control over each agricultural water source, the degree of protection of each agricultural water source, use of adjacent and nearby land, and the likelihood of introduction of known or reasonably foreseeable hazards to agricultural water by another user of agricultural water before the water reaches your covered farm. The considerations required under FSMA ProduceSafety rule are qualitative in nature. For example, is the water source very controlled by you, somewhat controlled by you, or poorly controlled by you? It requires the grower to make judgments to define the water sources. The other thing that a grower will see after following the criteria in 112.42a for a few years is the results likely will change very little if the water meets the water quality profile. These items serve to double-check everything that used to be true about the water system when the inspection was last conducted. It confirms that these things continue to be true and draws your attention to changes that could impact the quality of the water source. Regular annual inspections are not only a smart business practice, but they help build a robust food safety culture, and that is what the ProduceSafety rule is all about.
Lisa, we did have another question.
Great. I was trying to look at the chat and that's when I screwed up the video. But so yeah, let me know.
For the home gardener, is there anything we should consider when using rain barrels for irrigation?
Yeah, definitely. There's a number of things to consider, including you want to make sure that you have some, well, you can sort of start off by thinking about how you're using that water. So if you're using that water in your, in your garden where you're growing, your flowers and stuff, you don't have to think too much about it at all. There is a whole other kind of consideration that overlaps, which is for plant pathogens. So potentially water that you're collecting in a rain barrel or water that's in a, in a pond or anything that you're using for irrigation, anything that isn't your residential water has the potential to have plant pathogens in it too. So if you're using that in your garden, you have to think about that as well, but which overlaps with this human pathogen conversation. But specifically, if you're using it for your garden, and specifically for food crops, you might consider with your rain barrel to either not apply it to food crops or crops that you're going to eat, to your lettuce that you're growing, because it does have the potential to have pathogens in it, whether from, where it's landing and coming through your system, and then coming out the other end. There is that potential, and you have to think about what's the potential for that water to get contaminated. Like, do you have, there's the potential for birds on your house to like poop on the roof, and then the water comes down the roof and it may be collecting pathogens as it's doing that. And so you kind of have to think about what that potential is for that water to start with. And then you want to have some kind of sanitation kind of protocol for that. So you want to make sure that you're rinsing and maybe sanitizing that rain barrel and as much as you can the system as you go. There are filters that you can put on rain barrels that catch, at least the big debris, leaves and stuff like that. But there also are kind of like sand filters and stuff that you can use that may help to kind of work out some of the potential for it to be contaminated with other things. Some of the principles that we'll talk about in a second as I go through the slides will also apply in terms of like increasing the amount of time between when you apply it if you're using it for a food crop. So if you're watering your garden and you've just planted some lettuce seeds, you can use it for that. But if it's the day before you're about to harvest the lettuce to eat it, not using it then. So increasing that amount of time between when you apply it and when you harvest the crop. Does that answer your question?
Viv, is that the answer to your question? She says yes, thank you.
Right, thanks. Okay, so I hope you all like that video. I think they just did a really good job of helping give some idea about all the different components of a water system that you want to think about. But so once you've kind of thought about the system and all of the components of it, you can think about testing. Testing will give you an idea of the quality of your water. And as I mentioned, the rule as it's written requires quite a bit of testing. The rule as it's proposed, if that gets finalized, will not require testing for pre-harvest water, but will certainly, you can still certainly use testing as one of the tools that you have. And this goes for commercial farms and for home gardeners. You can also take tests to give you a sense of the microbial quality of your water. So again, for that, your rain catchment, whether you're doing that at home or on a farm, taking regular tests to give you an idea of what's happening in that system can be really helpful. Testing at the water source and the output is something that I recommend. It's not required, even in the rule as it's written, you're not required to test both at the source and at the output, but I think it's a good idea to test from different points in the system. What the rule does require is to take a representative sample that's appropriate for the water source. And so you have some flexibility to determine what that means, but generally you want to take water tests that, you're taking them close to the time that you're going to be using that water, close to the time of harvest, and even, around the same temperature that you might be using it. You take a water sample on the same kind of day that you might be using that water for irrigation. Don't take water tests, right after a heavy rainstorm. You're less likely to be using it at that point, and that's also a time when water is more likely to be contaminated with pathogens, because heavy rains can stir up sediment that might contain pathogens that, it might, there might be runoff from heavy rains that can contaminate or contribute to water contamination. So testing is one way to test the quality of your water. Generic E. coli is generally the indicator that we use for fecal contamination. There, you could test for all kinds of things. You can test for specific pathogens, but that gets really expensive really quickly and can be more work than it's worth. And what you're looking for is some idea of the potential for the water to be contaminated. So E. coli, generic E. coli, it's not a direct measure of the presence of human pathogens, but it is an indicator of the potential for the water to be contaminated with the pathogens that might be found in feces. So that's E. coli, Salmonella, Cryptosporidium, viruses, norovirus, that kind of thing. So fecal contamination is a risk factor for the presence of pathogens, and E. coli is a measure of the risk of fecal contamination, if that makes sense. And here's just a diagram that I think is kind of helpful to think about, because you can have water tested for total coliforms, which is the sort of broad category of organisms. And then within that broad category of total coliforms is specifically fecal coliforms. And then even within that category is this generic E. coli, and that's what you're looking for. So kind of in that category of E. coli is pathogens. And so, not all generic E. coli, there's in feces, generic E. coli is found. And so the idea is you're sort of associating the bacteria that might be found, or the bacteria that might be found in fecal matter as closely as possible. So you're not, again, measuring for pathogens, but for generic E. coli, which are very closely related, if that makes sense. And then this is also from the ProduceSafety Alliance training, and a general overview of how you collect a sample. And you can see from the picture from a couple of slides ago, you don't have to have these kinds of, this is just, I think, a PVC pipe attached to it might be a special tool, or it might be some homemade thing, but it's just attached to a cup. And the idea with something like this, like a pole like this, and I've seen people use fishing poles, that kind of thing. The idea is you want to kind of you don't want to stir the sediment up. So the idea with this is just you can collect the water without, touching any of the sediment or anything around it. And then this picture next to that is being taken from a wellhead. So you also want to make sure that you're not, touching the components itself, but that you're trying to get kind of as unaffected a sample as possible. So like I said, you want to take that sample as close to harvest as possible, or as close to when you're going to be using, as close to when you're going to use the water to have a representative sample. But certainly if you're concerned about whether or not that water that you're using for irrigation or anything else presents a risk, you want to make sure that you're getting it as close to harvest as you can. And again, don't stir up the sediment when you're trying to collect a sample. That's another picture of a guy using a long stick to help access that water, which that looks like that's like an irrigation canal that you would see in kind of the big farms on the West Coast. All of the labs, and I'll talk about labs in the next slide, but all the labs are going to have their own collection containers usually, and you can either go to the lab and get them, or sometimes they'll send them out. Some labs will actually have a courier service and can come bring you sample bottles, and I don't think they'll usually do the actual collecting for you, but they'll pick up your samples sometimes. But see these bottles, I often, if I'm in my office, I'll have some of these bottles on hand. I don't have any right now, but they're just like little plastic containers, and they'll be sealed usually to indicate that they're sterile. And a lot of them have like a powder in them, a reagent that helps. It's like a preservative for the sample. And so you really don't want to rinse the bottles before sampling them. You just open it, don't touch the inside of the container, and take the sample. Whether that's actually, in that picture, she had it right from a spigot or a faucet, and you can do that from the end of a hose, from the end of, from the spigot of your rain barrel. Or you might want to take a cup like this guy has and just sort of pour it into that container if you're taking like a surface water sample. And if you're doing it, you had that picture of the spigot, you want to, if you have it within a contained system, you probably want to run that water a little bit. So like flush it for a few minutes, 3 to 6 minutes or something, until the temperature stabilizes. And so that you're kind of getting a representative sample of the water that's in that system. So run it a little bit. Yeah, so that's about taking a sample, and in each of the labs are going to have their own protocols, and they'll share that with you. There'll usually be like a piece of paper that says like, do this, do this, do this, do this to collect the sample. And so the lab can really guide you through that process. And this map here is a map that is put together. The Northeast Center to Advance Food Safety is kind of our big educational hub for the Northeast. That it's an organization out of University of Vermont that I'm really involved in, and that that sort of gathers information from all of the Northeast region on food safety, and they helped to create this map where each of these, this is, I think I have it highlighted where just one of the labs is highlighted here, but I don't think I have, oh yeah, so if you just Google the things that I have at the bottom here, National Water Quality Testing Labs map, or this Food Safety Clearinghouse, which is where this map is housed, you can easily find this map. And again, I can share that link with you later as well, but it'll bring up this map, and it is a national map. So wherever you are, you can all of the different state extensions are trying to help contribute to making sure that this map is up to date and has a bunch of labs on it, so to make them easier to find. But if you click on anyone, and this is just a screenshot of me having clicked on this one lab. This is the one that's closest to me that a lot of growers use, called Howard Labs. That's in Hatfield, I think, in Massachusetts. And it'll give, so if you click on any one of these things, it'll give you some info about that laboratory, about whether or not they have, and if you scroll down, it'll have their contact information and stuff. It'll list, what tests they perform. And I'd also just recommend, this says, should growers call ahead? No, but I often recommend that people do get in touch and just say, whether it's this lab or any other lab, to say, I have surface water. Some labs won't take surface water samples because they're not set up to take water samples that might have like higher levels of sediment or something in it. So you might just reach out to the, find the lab that's closest to you, reach out to them and say, hey, I have this, whether it's a well water sample, whatever it is. How does it work? Can I come by there and get some bottles? Will you send them to me? Do you have a courier service? It's usually going to cost for the generic E. coli tests it could cost anywhere from $25 to $60. They're usually in like maybe the $50 range per test. So this is a really helpful way to be able to find the lab that's closest to you. And they really, like I said, they each one is going to have their own protocols that are going to be slightly different depending on their own methodologies and stuff. So it's good to make sure that you have like a good relationship with that lab that is closest to you. And then what you'll get for results, this is a picture of a result that was actually from that Howard Labs that I just showed you. This is a picture, this is an actual test result from a farm nearby here that I took. And this is what you'll get. And it's not going to say that much, but I've highlighted here this number. So this is the number you'll see. This is what you'll get. This is some number. This number happens to be 12. For the rule, the produce safety rule as it's written, your water tests have to be under a certain threshold. And you create, like I said, this water quality profile where you take a lot of tests and you sort of take the average of those tests over a period of time. And in the rule as it's written, what you're trying to be under is the recreational water standard, which is 126 CFU per 100 mils. That is the standard that like beaches have to be at in order for you to be able to swim in them. That's again the EPA recreational water standard. There's not a ton of evidence that that's a great number for irrigation water. We don't it's different to swim in water than it is to put water on your carrots or whatever. So that's part of that whole revisiting the rule, is like, is this really a meaningful standard, or is there a better way for us to assess the risks of water? And given the proposed rule that FDA just put out, I think they decided that this wasn't a great metric necessarily, but it is what we have to work with. And so you can kind of and it is the rule currently. So what you're trying to be is under that 126. And obviously this is a decent test. This is a good test result. 12 is this is from a river. This is from the Deerfield River, which obviously is like a dynamic water, not the Deerfield River, the Connecticut River. All kinds of things impact that water quality. And so to have a E. coli level of 12 is very good. And like I said, the proposed rule doesn't have that threshold for pre-harvest water. It does. You can't, yeah, that number has to be 0 for post-harvest water. But in general, what you're looking for is low numbers, and you want to test enough so that you can see trends and you can see changes and you can see spikes. So if you routinely you get tests, you take a test, a few times a year, and they're always kind of in this range, and then you get one that's 150 or 200 or whatever it is, you know that something changed, and you know that something that you want to go back to that, that distribution map, that your whole water system, and see like what's going on with this water. You're looking for that idea, that picture over time of your water quality. And so the sort of general rule of thumb that I put here is some testing is better than none, and more is better than less, and whatever you can kind of afford. And I'll talk about affordability in a second. I realize that we're getting close on time. So here's just some general thoughts about water testing. If you do have high results, or if you're not confident in that water source, the first thing you want to do is stop using that water if you're not confident about it, and try and figure out what's going on. In general, lower the risk by reducing contact with the crop. And one way to do that is by using drip irrigation rather than overhead irrigation for something like leafy greens. Drip isn't going to make a difference if you're talking about, carrots or something that's growing in the ground. But if you're talking about, peppers and tomatoes and whatever else, you might want to think about drip rather than overhead irrigation, because the less you can have that water contact the actual harvestable, edible portions of the crop, the better. And like I talked about earlier, just increasing that time between application and harvest. So again, if you're, if it's only applied at seeding or germination before the harvestable part of the crop is established, that risk is going to be lower. There are specific requirements around this in the current rule. There's what's called the log die-off rate, where water can't be so dirty that the pathogens wouldn't die off within 4 days is the standard that they've set. And you have to have that water quality profile with all the tests, and you have to calculate the die-off rate to see if that water is safe to use. And it's another part of that sort of cumbersome element of the original rule that I think helped them decide they wanted to revisit it. But so it goes, and I can talk to anyone more about that log die-off rate if they're interested. But the idea is basically like extend the amount of time between when you're applying the water and when you're harvesting. And then the final point on here is treat the water. And I have a slide on that. This is not common in the Northeast. There are chemical sanitizers. Chlorine and peracetic acid are the two most common. Peracetic acid, also known as PAA, is the main ingredient in products like Sanidate that some growers are familiar with. And then there's non-chemical options like filters, UV, ozonation. Some of these, so the reason we don't talk about this too much is that at this point, let's see, what do I say here? There are certain antimicrobial products that are labeled for use in the treatment of irrigation water systems or irrigation ponds to control bacteria and algae. But at this time, there are no EPA registrations for pesticide products. These are chemical sanitizers are all considered pesticides for antimicrobial treatment of ag water used during the growing of crops for human pathogens. So, and that's something that EPA and FDA are kind of actively together working on. Like I said, there are products like BioSafe is a company that makes Sanidate and Oxidate and a bunch of other things. And some of those things can be used to sanitize irrigation equipment to reduce the biofilms potentially that build up in that equipment. So your, irrigation pipes and stuff. Or sometimes that treated water can be applied to crops for control of plant pathogens. Like Oxidate is one that can be applied to crops. Sanidate can be applied to crops, I think, in a particular formulation. But in general, there's, environmental issues potentially with putting sanitized water directly onto a crop or a field. Some of these treatments may be required eventually for the kind of big growers under leafy greens marketing agreements and things if they're using like surface water, pond water, and canal water and stuff. It's not. We just haven't quite gotten to the point where water treatment at the time of irrigation is something that we're like scaled to do in the Northeast. And I don't have a lot of experience with it. And it's something that a lot of extensions are working on. This picture that I've included is a picture of a UV device. And so you can see this inlet here is where you would put this on your pump and the water would come through here. And depending on how, you know, the flow of the water and the time it spends in this channel, it'll kill the bacteria that's in it. And then it'll come out the other end and won't make it. So there's no chemical coming out the other end. It's just sanitized water. And so I think devices like this do have some promise for small growers. They can be scaled up or down. And this is something that I'm actively trying to learn about. I don't have experience with these water treatment devices, but I just wanted to mention it just because water treatment is included in both the proposed and the rule as it exists as an option for water. And it's just an option that I think will become more attractive to people over time and probably more in line with these devices rather than like just putting bleach in it. But they are options, and it's just something that I'm trying to learn more about. And if you do have questions about that, I'm happy to like help you think through the options that exist. But again, I don't have a ton of experience with treatment, but it's important to mention that it's a potential possibility. So here's just a summary of kind of the pre-harvest water management section overall, is that you want to map out the system, inspect it regularly, definitely at least annually, whether you're covered by the rule or not. Just make sure that you have sort of a sense of what the water on your farm is. And that includes the water that you're intentionally applying, but also, like I said, all that kind of other water that moves around your farm and that surrounds your farm. And particularly when you do have, you know, when you're washing with water and there's water moving into your fields, just making sure that that water isn't becoming a source of contamination based on kind of the understanding that you might have about how it might become contaminated with fecal pathogens. You can test your water. Currently, again, the rule requires that some growers do, although waiting on final results about that. But you want to test it, review those test results, and look for trends. And if you do have doubts, or if you think the water quality might be low, stop using it and try and figure out what's going on. Use less risky application methods. Drip is definitely less risky than overhead. Anything where the water isn't directly touching the crop that you're going to harvest, and then increasing that time between application and harvest. And like I said, treatment is a potential possibility. And I realize we only have a couple minutes left, and so I just wanted to tell you about this project. There's still a lot to learn about water, as I kind of maybe alluded to. How risky is it? What's the best way to sample it to get the most useful results? The best way to take a representative sample. So I worked with the Department of Ag to put together this specialty crop grant, where it's a 3-year project, and part of it, these are the objectives of it, where we're usually like not a lot of people test water. There just hasn't been hardly anyone in Massachusetts test their water. I think farmers in particular, they've never been required to by law. It has been required by some audit programs, but it's really a big area of noncompliance even in those programs. So we just kind of want me personally, and as an educator, and I work very closely with the Department of Ag and their ProduceSafety inspection program. And so together we wanted to kind of get a better understanding for ourselves about what people were going to get into if they started to test their water, and what they might see, and to get a better idea of just sort of the ins and outs of testing water. Like, how hard is it to kind of scurry down a muddy bank to take water samples, and just give us a better idea of what growers are facing. So we have this project that is going to allow me to take a bunch of water samples from around the state and kind of establish what we're calling a water quality baseline. So, you know, not testing every water source in the state, but hoping to just get more experience with water testing and figure out just sort of how contaminated is some of this water that people might be using, and what do we have to kind of prepare ourselves for going forward. So again, enhancing the expertise within our team at Extension, and then the ProduceSafety team that provides technical assistance and support to growers in the state of Massachusetts. And so then we'll provide education and technical support based on kind of what we find, and maybe put out, you know, fact sheets and workshops and one-on-one farmer assistance based on what we find. And then I also want to mention that there is a big part of the grant is cost share funds to specialty crop farms in Massachusetts. So they're still working out that cost share program, but I think they're hoping to establish contracts directly with several of those labs. So a bunch of the ones that I showed on that map, so that growers can submit their samples to the lab, and the labs will get reimbursed directly by the state. So the growers won't have to pay for, up to some number of water tests per year. And I think we budgeted for $200 per farm per year. So that's about 5 tests per year per farm for that 3-year grant period. And budgeting, it's a first come, first serve probably, but there's a chunk of money in there. So hopefully they'll work out the details for that, and we'll certainly advertise how that works. And once we get that settled, we'll put that out in our newsletters and stuff from UMass Extension going forward. I think that's all. And then we're right at time. And I just wanted to share a couple resources. Our UMass Food Safety for Farmers website has a ton of this information and others related to the different topic areas that I talked about. And then the MDR ProduceSafety program website also has a ton of information about the rules and also their technical assistance and grant programs and how to access assistance there. And I also just wanted to share the website for the ProduceSafety Alliance, which created that curriculum that I've mentioned, the grower training curriculum. And I do want to say that we'll hold a couple of these remote grower trainings. They're going to be remote in February and March. I don't have them scheduled yet, but they are coming up. So if you do have interest in going through like an all-day produce safety training and getting certified, certainly reach out to me and look in our Vegetable Notes newsletter that comes out of UMass Extension for more information about that. Thank you.
Thank you. We do have one more question from Vilma. Is heat ever used for sanitation? Thinking of places where boiling water is necessary before consumption.
It is, well, certainly heat is used for sanitation, like an autoclave, in a lab or something like that. That's how you would sanitize equipment. It's not necessarily the most practical choice for farmers. Certainly if you're talking about a farm or a house, it might be a different situation, like boiling, you might get a boil water order from even your town if there's some issues with E. coli in your town. But on a farm level, heat isn't usually the most practical tool, I would say. There are like steam cleaning equipment and stuff like that people sometimes will use for like harvest bins and stuff, but there's still some like data lacking on whether or not that is hot enough in that, or like the way that it works is that you'd actually practically be able to kill pathogens on, the surfaces of things. And then there's also this idea that you can like aerosolize pathogens in if you're like spraying something with force. So there's a lot of things to think about, and you can also just hurt yourself with a steam sprayer. But so heat definitely works to kill pathogens. The practicality of it depends on the situation.
Okay, thank you so much. Well, we do have to go. It is now 12:30, and I want to thank everybody for being here. And Lisa, thank you for the presentation. And we'll hopefully see you later on this afternoon.
I'm just going to put my email in the chat in case anyone does have questions or wants resources or just wants to have a phone conversation about any of this stuff. I'm always happy to talk food safety with anybody, and please reach out. I'm very available to talk through any of this stuff or share any of the resources that I talked about. So be in touch and enjoy the rest of the conference. Thanks for coming.
Thanks.
Thank you.